So this is going to be lesson 6.4. Rhombi and squares. Rhombi is plural for rhombus. It's a shape. I know, you're all shocked. It's a shape. If you notice, it has all the same properties of a parallelogram. We've seen a trend here, all the properties of a parallelogram. So, except that a rhombus has all sides congruent. All the sides are congruent, which means they're all the same. What other shape do we know where the sides are congruent? A what? A square, right? So we think of a rhombus as a slanted square. So if I'm going to draw it, kind of looks like this, where all the sides are the same, but it's kind of slanted. And if I know all the sides are the same, I can mark them all congruent. Something else that's new is that the diagonals are perpendicular. Diagonals are perpendicular. What kind of an angle do perpendicular lines give us? Remember, this is the perpendicular symbol. What's created down here in the corner? A right angle. So when you have the diagonals in a rhombus, they're not congruent, they're not the same length, but you've created 4 right angles there in the middle. And the new thing also about a rhombus is that the diagonals bisect opposite angles. So they bisect opposite angles. We already know from a parallelogram the opposite angles are congruent, but if it bisects opposite angles, it's going to look like this. These two right here are the same. Can you guys see where I drew that? Those two pieces, those two angles by D are the same. But then so are the two angles up by B. So actually all 4 of those angles are exactly the same. And likewise, these down here by C are the same, and they're the same as the ones by A. Okay, so I just drew 2 arcs there. It's a lot to try to remember, so you're not going to have to memorize all this. We're going to work through a few of them together. Okay, so let's look at example 1. Go ahead and label your diagram on example 1. They tell you that JK is 12 and JN is 7. They want you to find everything else, all the other sides. Well, if JK is 12, what do we know else? What? ML is 12. But what does number 1 say up there that we just wrote? All the sides are the same. So not just those 2 sides are 12, but what? JM and KL are also 12, right?
And then will all of them on the inside be 7 too?
Nope, they're not all 7. NL is 7 though, because the diagonals bisect each other. But we are going to have to think about what they said on number 2. Number 2, it said the diagonals are perpendicular. which creates a right angle right here. And if I know two sides of a right triangle, how do I find that third side? Say louder, but Dalton.
C squared equals B squared plus A squared.
C squared equals A squared plus B squared. Dalton, or I'm not Dalton, Donald, which one is your C value?
It's 12.
12, good, because it's across from the right angle, right? So I know that 12 squared equals 7 squared plus B squared. That's going to give me the other piece of the diagonal. And I think it does come out to be a decimal, which is okay. Just round it to the nearest tenth. I'm getting 9.7. Is that what you guys are getting? So this right here, NK is 9.7, which means so is MN is 9.7. Okay, and now we can go through and label what they've asked us. So JM, 12. JL, how are we going to figure JL? Okay, so Sebastian, what is it? Good. 7 plus 7 gives me 14. MN, we wrote as 9.7. And MK, what are we going to do to find MK? 9.7 plus 9.7, which is? Good, 19.4. Okay, any questions about number 1? Okay, let's look at number 3. If RT is 22, guys, how much is each of the little ones? Okay, so let's just go ahead and make it 11 and 11. That might be easier for us to manage. So RV is 11 and VT is 11. And then what about US? If US is 18, then VS and UV are how much? 9. How do you think we're going to find the outside edge here? What? Pythagorean theorem again, right? Because I have another, you could do this any triangle, but I have a right triangle, right? Which one is my C value, Daniel? C is the one we don't know, right? So C is that one up there that we're not sure of, okay? So I have C squared equals 11 squared plus 9 squared. And again, you'll get a decimal, which is okay.
You sure?
Am I sure that you get a decimal? Did you not get a decimal?
No.
What did you get?
15.
Even? 81 plus 121 is
Oh, 121. Never mind.
202.
That's my fault.
Okay. I'm getting 14.2. Is that what you guys are getting?
Yeah.
Okay. So we know that this side is 14.2. But then what else do we know about this whole rhombus? All good. All the sides are 14.2.
Instead of writing 14.2 on each side, can I just mark them off the wall?
Sure. It's your diagram as long as you know what that means. All right, so let's go through and label. VT is how much, Ashley? 11. UV, Kaylee? 9. UV is 9. RS, Sebastian?
14.2.
Okay. ST, Vinny?
14.2.
Good. Questions on number 3? You guys feeling okay with this? It's just kind of remembering what the properties are for which one, okay? So let's do number 5 together. Let's just work with the sides first. Go ahead and label your sides. there's anything else you know, go ahead and label all that. WY is 38, so what's half of 38?
19.
Okay, so WV is 19 and VY is 19. But do we know how long that other one is? No. How are we going to find it? Okay. A squared plus B squared equals C squared. Michelle, which one is going to be my C value?
34.
Good, 34. And again, you get a decimal, which is okay. Abby, what did you get for B? What did you get for the B value? Or whatever missing value? Good, 28.2. Anybody else get 28.2? Okay, you should get 28.2. It's our missing piece in there. Okay, so let's figure out what they are asking us to do then. They're asking us for WZ, we know is 34.
I hear something wrong.
With finding 28.2. Okay,
I got 22 point something.
just write 28.2 and then I'll help you with your math in a minute, okay? VY, 19. ZV, 28.2. And ZX, to find ZX, we're just going to double that, right? 28.2 times 28.2. 56 what? 56.4. Okay, now they're asking us for our angles. What do we know about the angles in the middle, first of all? They're all 90. So let's draw that before we do anything else. We know that all those angles in the middle are 90. And then it says that ZXY, from Z to X to Y, is 34. Okay, if this is 34, remember in a rhombus, the diagonal splits it, right? So if this side of the line is 34, then up here is also 34. So in a rhombus, we know that that gets split. And then that means that both the angles down by Z are both how much? They're both 34 and 34, okay? Now, you have some triangles here. And in a triangle, all the angles add up to be how much? 180. And if I have this triangle here, and I know that I have 34 and 90, can I figure out how much this guy is down here? Could I do that? Okay, we could take 34 and 90 away from 180, right?
Yeah.
Okay, so let's do that. 34 and 90, and then subtract that from 180. What'd you get? 56. Anybody echo 56?
Yes.
Okay. So if this is 56, then what else do we know? The other side is 56, and then angle what? Both the angles in W are also 56, right? Okay? For the sake of time, I'm going to let you go back and fill this part in because we've done our diagram, so you can go and fill that in later. Okay? We got our last page to do, and then we're done. The best for last, which is a square. In a square, everything just matches up so nicely. It says a square has all the properties of a parallelogram, a rectangle, and a rhombus. So everything we've learned so far about diagonals and right angles and all that kind of jazz is true in a square. Everything works nicely in a square. Now, let's talk about this, though. Let's quickly draw a square.
I did the show.
All the corners are how much? 90, because it's a property of a rectangle, right? And not only are they 90, but remember in a rhombus they get split. So how much is each angle in the corner? What? 45. This angle's 45. This is 45. This is 45. This is... In a square, all those angles on the side are 45.
All the time?
All the time. And in the middle, they're always what? 90. So that's the nice thing about a square. You don't have to think about it. They're all 45, 45, 45, 45, 90. Okay? So, let's look at number 7. So skip number 6 and go with me to number 7. See what information you can come up with. Okay? I'm going to let you do this one on your own. It says that TR is 17. See what else you can do knowing that. Okay, so because I know that opposite angles are bisected, I can set them equal to each other in a rhombus. Get 3x equals 21. So x is 7. Now, it asks for FED, which is all the way over here. And we know in a parallelogram that consecutive angles are what? No, not the same. They equal 180, right? So if I could figure out how much these blue angles are together, I could subtract that from 180. Would you guys agree with that?
Yeah.
Okay, so if I plug 7 in, 7 times 35 plus 1 is 36. So this little angle is 36, which means the other one is also 36. So together, 36 and 36 is 72. So this angle over here is 72. And remember, the two of them add up to be 180. So if I've used up 72, how much is left? 108 for this angle over here. So I know that the measure of angle FED is equal to 108. And you need to put this on there, that last thing, okay? Questions about number 9? That one was a little loaded. Okay, yeah.
How do I know to use 72 and not just 36?
Because we know that these two in a rhombus, this whole angle and this whole angle make 180. And if you only take 36, you're only taking part of it. Does that make sense?
Yes.
Okay. All right, let's do number 11 and then we'll go on break.
I'm so cold.
Okay, it says if FGHI is a square, solve for x. They gave you 7x plus 3 as one of the little corner angles. In a square, how much do we know a little corner angle is? Say that again, Donald. 45. It's a square, so we know that each of these guys are 45. So we can take our 7x plus 3, set it equal to 45. Yeah, the squares are the fun ones. You don't really have to think about it, right? So 42 divided by 7 is 6. Be back at 2:15, please.